Hey guys, good morning. How's everybody doing today? Happy April Fool's Day. Little clown for you guys. Knees weak, arms are sweaty. Vomit on your sweater already? All right, let's get started. All right. Look, all my girls are here. All right. All my girls and Uriah. Cool. Okay. All right, so here's what we're gonna take a look at today. So last time we looked at multiplying complex numbers last week on Friday. Today we're gonna finish up the second half of that um, lesson, kind of split it up into two. So today we're gonna look at the dividing. Oh, happy birthday, Uriah! Happy quarantine birthday. We're gonna take a look at the dividing complex numbers. Okay, so the first thing that we need to discuss when it comes to dividing complex numbers is this term called a conjugate. Okay, so oh, by the way, we are doing this is for period 4. Yes. Today we're doing 6 boxes. Okay, 1, 2, 3, 4, 5, 6. So go ahead and set that up. All right. So first term, first definition here, we're looking at something called a conjugate. Okay, or otherwise known as complex conjugate. Okay, so you might hear it in different ways. The reason why they might include complex conjugate is because you're dealing with the complex numbers. So just know that it means the same thing. Okay. Wow. Okay. You made me give you a birthday shout out when it wasn't your birthday. Cool. Cool. All right. So what is a conjugate? Okay, so the simplest way to kind of consider to think of what a conjugate is if you have a complex number written in any form, right? If it's in the form of a plus bi, then the conjugate is simply achieved by negating the imaginary part. So in this case, you see how you have a plus bi. The conjugate would simply be a minus bi, right? So you basically multiply the imaginary part by a negative. Okay. If it was the other way around, let's say you started with a minus bi, then your conjugate would be, right, negating the second term, which then turns it back into a plus bi. Okay, so it's basically just the opposite of whatever the imaginary term in the complex number happens to be. Okay, so the way you can find the conjugate, okay, it is formed by negating. Okay, negating just means multiply by a negative. Okay, negating the second term of the binomial. Okay, I'm calling it a binomial because you have two terms, right? So it's basically just negate the second term. So that's really all that changes when you're looking for a conjugate. Okay, so today a lot of what we're going to do is we're going to utilize conjugates to be able to divide these complex numbers. Okay. All right. Okay, so let's just practice real quick what complex conjugates are, right? So like let's say you are given a couple of complex numbers. Let's say you are given 5 minus 3i, right? And you are told to find the conjugate. Okay, sometimes you might see it as like reciprocal. Technically, I guess that's okay as well, but I want you to utilize the word conjugate. All right. So what would the conjugate be for this term? Well, remember that we said we would just negate the second term. So the conjugate would be 5 plus 3i. Okay, pretty easy. All right, what if we had something else that looked like -2 plus 5i? Okay, what would the conjugate look like in that case? Well, remember, you're only negating the second term. So if the original, if the real value, right, this -2 is negative, it's going to stay negative. Okay, you don't change anything to the real term. The only thing that ever changes is the imaginary term. Okay, so then that becomes -2 minus 5i, and that would be the conjugate for that complex number. Okay. All right. Are we okay? Any questions so far? All right. Yeah, it's pretty easy so far. Okay, so okay, let's take a look at some real examples then. So now for example number 2. All right, we want to divide this complex number. Okay, so what we start with is 5 minus I all over 2 plus 3i. Okay, so the problem that we have here is similar to what we looked at when we first looked at imaginary numbers. Is we don't want to have any imaginary terms in the denominator. Okay, so if you do have imaginary terms in the denominator, then that's your problem. You have to then get rid of it. Okay, so what we do here is we're going to utilize the conjugate. Okay, and here's, make a note about how we're going to use it. Okay, so we are going to multiply by the conjugate of the denominator. Okay, why do we multiply by the conjugate of the denominator? Well, because the denominator is the one that's causing the problem, right? I can have I in the numerator, right? So this I that's up here, that I is fine. That's not causing any issues. What's causing an issue is the 3i down here, right? That imaginary term is creating issues. So what we do first is we look for the conjugate of the denominator, right? So the denominator is 2 plus 3i, so the conjugate would be 2 minus 3i. Okay, so we're going to multiply this conjugate, 2 minus 3i, to the denominator and to the numerator. Okay, and there it is. That's all we do. Okay, so now what it becomes is just a product. It's a multiplication problem now. Okay, because you know that if you have two terms in the numerator, you can multiply those, then you multiply the two terms in the denominator. Okay, the whole point of multiplying by the conjugate is that it's going to help you eliminate the imaginary term from the denominator. Okay, so watch what happens. We multiply 5 times 2 in the numerator, that's going to give us 10. 5 times -3, that's going to be a -15i. Negative I times 2 would be a -2i. And then negative I times -3i would be a positive 3i squared. Okay, so we get multiple terms in the numerator. We're going to clean them up in a bit. All right, now the denominator. All right, let me get rid of these so they're not in the way. The denominator, now you're going to multiply, same thing, you're going to FOIL, right? So you multiply 2 times 2, that's 4. 2 times -3i, that's going to be a -6i. 3i times 2, that's a positive 6i. And then 3i times a -3i, that'll be a -9i squared. Okay, so let's clean up now. Let's start with the numerator. Okay, I have 15i minus 2i. Remember, these are like terms because they both share I. So they're both imaginary terms. We can combine them. Okay, so at least for now, we can say this is 10. -15 minus 2 would be -17i. And then the 3i squared, we can rewrite this as 3 times -1. Okay, all right, let's clean up denominator a bit. I have 6i. I'm sorry, -6i plus 6i. Okay, what do we know about those two terms? Well, -6i plus 6i is going to cancel, right? They're going to add up to be 0. Okay, that's something that you want. When you do this correctly, in the denominator, those two middle terms, these two right here, will always cancel out, or at least they should. If they don't cancel out, you probably made a mistake with your algebra. Maybe you multiplied and you brought down the wrong sign. Okay, so the whole point, remember, of multiplying by the conjugate is to eliminate the I from the denominator. So by having those cancel out, it's a good start. Now, the other piece is, notice that this is I squared, right? So then that's going to change back into a -1. So here's what we get. Now we get 4. That's a -9, so -9. And then the I squared becomes -1. Okay, so now here's what's happening. In the numerator, 10 minus 17i plus 3 times negative 1. Well, if I multiply those two together, that becomes negative 3. Okay, well, I have real numbers now. This is a negative 3, and that's a 10. So then that simplifies to be 7. And then minus the 17i. Okay, so that's my numerator. That's about as far as I can go. Okay, remember that one is real, one is imaginary, so they don't combine. In the denominator, you have 4, and then negative 9 times negative 1 is going to be positive 9. Okay, so here's what you get. You get 7 minus 17i all over 13. Okay, do you see what we achieved here? We ended up with a real number in the denominator. That was the whole point. Okay, there's no longer an I down there. Okay, so when you divide, you basically use the strategy of a multiplication. You multiply by the conjugate of whatever complex number happened to be in your denominator. Okay, so you focus here, right? What do I have? What is the conjugate of that? Well, the conjugate would be 2 minus 3i. You then multiply that to the top and bottom, and then you multiply, you FOIL, and you condense. Okay, when you get to the end, you should get a real number in the denominator. Okay, now one quick note is, remember that real numbers are supposed to be written in the form a plus bi. Okay, which means you need the real part plus, or it could be minus, the bi. Okay, notice how right now I don't have that. I don't have them separated. I have it all under one denominator. So I'm going to split this up, and I'm going to write it as 7 over 13 minus 17i over 13. Okay, why do I do that? Because I want to see the separation. I want to know what is the real component. I want to know what is the imaginary component. So I split it up to be in what we call standard form. Okay, this would be the standard form of a complex number. Okay. And that's pretty much it for the first example. Okay, so you can see now that this part, the 7 over 13, that's your A. And then the 17 over 13, that's your B. And then you have your I, right? So there is the form, the standard form of A plus BI, or sometimes it's A minus BI, depending on the number. Okay. Okay. Let's take a look at the next example. Okay, so 4 minus 3i all over 2 minus 4i. Okay, again, have issues, right? I look at my denominator. That denominator is a complex number. Part of the complex number is imaginary, and we don't want imaginary. So I need to go ahead and multiply this by the conjugate, right? What would the conjugate be of 2 minus 4i? Well, the conjugate there would be 2 plus 4i. Okay, so then we multiply 2 plus 4i to the top and the bottom. Okay, remember why we're allowed to do this. 2 plus 4i all over 2 plus 4i, that's the same thing as multiplying by 1, right? When you multiply by 1, you're not changing anything. It's just going to look different, right? That's why we're allowed to do this. It's very similar to what we did in notes, I believe, 35, right? Similar process, but now instead of just imaginary, we're multiplying by complex. Okay, so again, same process now, right? We just FOIL out. So start with the numerator, 4 times 2, you get 8. 4 times 4i, that's going to be 16i. Negative 3i times 2, that's a negative 6i. And then negative 3i times a positive 4i, that'll be a negative 12i squared. Okay, denominator now. Let me erase these. All right, let's FOIL. 2 times 2, 4. 2 times 4i, positive 8i. Negative 4i times 2, negative 8i. And then negative 4i times 4i, it would be a negative 16i squared. Okay, so let's clean up the numerator. Okay, in the numerator, you're going to have 16i minus 6i. That's going to become 10i, right? So you can start by saying, okay, that's 8 plus 10i minus 12. And then the I squared, you convert to a negative 1. In the denominator, check it out. 8i minus 8i, that cancels, right? That you're supposed to get that. That's supposed to happen, all right? If those terms don't cancel, something went wrong. Okay, so now you can say, all right, well, that's just a 4 minus 16, and then we make the conversion here again. I squared is a negative 1. Okay, so let's keep going. Let's clean up a little bit more. All right. Well, here, negative 12 times negative 1 becomes positive 12. So really what you have is these real numbers of 8 and 12. So if you add them up, that's 20 plus 10i. Okay. In your denominator, negative 16 times negative 1 is positive 16. So that becomes 4 plus 16. So then you get 20 in the denominator. Okay. You've achieved the goal of having it as a real number. It's no longer imaginary, right? That's what you want. But you want to break it back into standard form. So you want to split it up so that each term in the numerator has a denominator of 20. So you get 20 over 20 plus 10i over 20. Okay? And then from here, do you see why we split this back up? Because now I have something I can simplify. I can clean this up. 20 over 20 is 1. Plus, here in the other denominator, the other fraction, 10 and 20, those can be reduced. You divide top by 10, you get 1. You divide the bottom by 10, you get 2. So what's your new? It's going to be 1 over 2i. All right. So then there's your real number. There's your complex number, 1 plus 1/2 I. And that's the benefit of being able to split it up back into standard form. It helps you reduce where possible. Let's move on. Okay. Example number 4. Okay, so we're going to add a little bit of an element of a little bit of a challenge. So we're going to start here with 2 minus I root 3 all over 2 plus I root 3. Okay, so the added element of kind of the challenge is having to work with that square root now. Okay, but still, same idea, right? Look at the denominator. There's a term there that has an imaginary, right? The second term, that's imaginary. So your process is always to then look for that conjugate. In this case, it's going to be 2 minus I root 3. Okay, and then you multiply that to the numerator as well, 2 minus I root 3. Okay, so now let's expand. Let's multiply this out. 2 times 2, 4. 2 times I root 3. Okay, remember when we talk about where we put I? Remember that, okay, if the problem gave us I in front of the root, then when we do it, we need to put I at the end of the root. Okay, we shouldn't have I in the front. That does not go with the standard convention in which to write complex numbers. Okay, so if I multiply 2 times root 3, or negative root 3, it's going to be negative 2 root 3, and then bring the I to the back of the expression. Okay, I should not be in between. Okay, same thing here, right? You're multiplying 2 times negative I root 3. Well, you're going to get another negative 2 root 3, and then move I to the very back. All right. Okay, and then lastly, you're multiplying this negative I root 3 times the negative I root 3. Well, remember that if you have roots, you can multiply the square roots, the numbers inside those square roots together. Okay, so you have a negative times a negative, so that's a positive. You're going to get positive root 9. And on top of that, you can multiply I times I. So that's going to give you I squared. Okay, so there's quite a lot to simplify in that numerator, but we'll get to it. In the denominator, let me erase these. Okay, in the denominator, we get 2 times 2, so that's 4. 2 times negative I root 3. Okay, so that's going to be a negative 2 root 3i. Then you multiply I root 3 times 2, so that's a positive 2 root 3i. And then you multiply basically what you had in the numerator, right? Except that the sign is different. So that's going to be a negative. Root 3 times root 3 gives you root 9. I times I is I squared. Okay. Here, it is extremely important not to cancel things out. You're going to be super tempted to want to cancel out the things in the denominator with the things in the numerator because they look identical. And you're thinking like, oh, I could just cancel everything out. Do not do that. Do not cancel. Do not cancel anything. Okay? I've seen it before, and it is not the correct way to do it. You need to simplify the numerator first, then simplify the denominator separately. That's why I have them in separate colors right now, because I need to treat them as if the denominator is not there, and then I have to treat the denominator as if the numerator is not there. Okay, you got to clean this up first. Okay, so first thing, in the numerator, I have a 4, bring down the 4. Okay, now here's the next thing. I want to see if I can combine these two middle terms, right? Because they're both imaginary, first of all, right? They both have I, so it's likely that I can. But in order for me to be able to combine the like terms, they need to have everything in common, which means if this is my coefficient, right? If I have -2 as a coefficient and a -2 as a coefficient, they both need to have exactly the same terms, which means they both need to have root 3. Do they both have root 3? Yes. Do they both have I? Yes. So then I'm allowed to combine those coefficients. So -2 and -2, that's going to become a -4. But -4 what? That's where you bring down the root 3 and the I. Okay, so you can combine the coefficients only. Everything else, you treat it like a variable. You just bring it down. Okay, now for the last part, you have plus root 9, that's a 3. And then I squared, that's just -1. Okay, and we'll clean that up in a bit. All right, denominator, okay. 4, bring that down. -2 square root of 3i plus 2 square root of 3i, okay? So again, you do the check, right? If you want to combine these two coefficients, the -2 with the +2, do they both have the same terms? Do they both have root 3i? Yes, they do, right? So I can combine those two together. Well, -2 plus 2 is 0, right? So if it adds up to be 0, then everything goes away. Okay, it completely cancels. Nothing comes down. Okay. All right, now we keep going. We have minus, well, root 9 is 3, and then the I would be a the I squared becomes -1. Okay, so now in the numerator, right, if you were to multiply the 3 times the -1, that gives you -3. So now you have two real numbers here. You have a 4 and a -3 that you can combine. So when you add those together, 4 minus 3 is just 1. Okay. Then you can bring down the -4 root 3i. Okay, denominator, -3 times -1, that's going to be a +3. So you end up with 4 plus 3 in the denominator, which ends up giving you 7. Okay. All right, we're pretty much done. What I would need you to do now is to then split this back up, right? Write it in standard form. So then you would get 1/7 minus 4 root 3i all over 7. And that's it. Any questions on that problem? Okay. All right, and now let's take a look at this last problem. This one is one that I'm gonna pull. It's very similar to one that I saw in the homework, so I want to make sure that you guys understand how to do it. So here's like a little extra one. So example 5. It's gonna be a combination of like function notation and then complex numbers. Okay, so you're going to start off with a function. Let's say it's f of x, and they tell you that f of x is equal to x plus 1 over x. Okay, and then it tells you find the function if it's evaluated at 1 plus 3i. Okay, so we've done things like this before. This is very similar to composition of functions, where you had to take one expression, and then plug it in wherever you see x. Okay, so here, right, whatever's inside of one, right, whatever's inside of these parentheses, the 1 plus 3i, that's what you're going to substitute for your x value. Okay, so you're going to substitute it here for x. Wherever you see x, plug it in. Okay, even here. Okay, now, so this part is just going to be notation, right? So you have f of 1 plus 3i, and then that's going to equal, well, instead of x, it's 1 plus 3i plus 1 over 1 plus 3i. Okay. And then from there, you're like, what now? Right? What now? Because, oh, sorry. First of all, you have a whole, not a whole number, right? But you, in a way you do, right? You have 1 plus 3i plus 1 over 1 plus 3i. First of all, that denominator right there, it's like trying to add, it's like if you were trying to add 1 plus 3x plus 1 over 1 plus 3x, right? That's the idea, okay? You have something that's in the denominator and it's imaginary, right? So you got to treat that separately from whatever's going on here with this 1 plus 3i. Okay, so worry about that later. For now, your job is to make sure that any I that is in the denominator is no longer there. Okay, so we go back to using the conjugate, but we're only going to multiply it to the fraction, not to the expression that is the numerator. Okay, so here's what I mean. So I'm going to take the conjugate of 1 plus 3i. That is 1 minus 3i. Okay, then I multiply that to the numerator. Okay, so here's what I'm going to multiply. Only, okay, let me kind of split this up for now. I'm only multiplying these two terms, okay, these two expressions. Okay, I'll worry about whatever I get with the numerator. I'll combine it later. Okay, so for now, go ahead and just distribute the 1, right? Well, 1 times 1 is 1. 1 times negative 3i is just negative 3i. Okay, all over. All right, now hopefully by multiplying by this conjugate, I'm able to at least get rid of the I from the denominator, and then I can, then I can go ahead and do something different. Okay, so now here we multiply 1 times 1, that'll be 1. 1 times negative 3i, negative 3i. 3i times 1, positive 3i. And then the last term, that'll be a negative 9i squared. Okay. So now, denominator, let's clean it up, right? You see those two terms? You got negative 3i and positive 3i. Those cancel. Okay, let's rewrite what we have here. This is the same thing as 1 minus 3i all over 1 minus 9 times a negative 1. Okay, so then that's going to be 1 minus 3i all over, well, negative 9 times negative 1 is positive 9, so that's really 1 plus 9, so that's 1 minus 3i over 10. Okay, so now I have this new situation, I have this new problem. Okay, so now I can bring down the 1 plus 3i. Okay, so here's what we can say. We have 1 plus 3i, which I'm bringing down from here, plus whatever I got, right? This was the other half of the problem. So now I can add that to 1 minus 3i all over 10. Okay. Now, you cannot, at this point, add those numerators yet, because I want you to think about this as 1 minus 3i. That entire expression has a denominator of 10. Okay. The other expressions, they don't have denominators, right? So it's like thinking of fractions. You can't add the fractions unless they have common denominators. Okay, so here's what I want you to do first. This is where, again, splitting it up and writing it as standard form helps to see what needs to be done. So I'm going to rewrite this. Let me bring it up over here. 1 plus 3i plus 1 over 10 minus 3 over 10i. Okay. So now this is my current problem. Okay, this is what I want to do. Well, I can't add a whole number with a fraction, right? They're both real numbers, but I can't add them because they currently don't have common denominators. Okay, so that means that I would need to multiply this 1 right here, put a denominator underneath, and in order for it to have the common denominator, I'd have to multiply it by 10 over 10. Okay, so then that gives me 10 over 10 I'll bring this down as 1 over 10. Okay. Same idea with the 3i, right? In order for me to be able to add the 3i with the 3 over 10i, it needs a denominator of 10. So what do we multiply here? Multiply 10 over 10 to this fraction. Okay, so then we're going to get plus 30i over 10 minus 3 over 10i. Okay, now that everything has a denominator of 10 and we have the reals separated from the imaginaries with different colors, now we can actually go in and combine, right? So you have 10 over 10 plus 1 over 10. Okay, that's going to be 11 over 10. Then you also have 30i over 10 minus 3i over 10. Okay, so now because they both have common denominator, all right, that's going to be all over 10, right? That's 30 minus 3, so that's 27. And then obviously it's an imaginary, okay, and that's a positive 27. So then, right, you're done because it's already in standard form as well, right? You can't reduce the 11 divided by 10. You can't divide 27 by 10 either. There's nothing to reduce. So then this is that's the final. Okay, are there any questions on today's lesson? Okay, how do we feel? We're good? All good? Okay. All right, couple quick announcements. All right, so technically Friday there's no school, right? It's a spring break. So, but I was planning on giving a quiz. So here's what I'm gonna do. Okay, I'm gonna post the announcement later on the classes. Yeah, the last one is tedious for sure. Okay, so the unit 6, we're gonna have a first quiz. It's gonna cover notes 35 and notes 36 only, okay? It's gonna be on Edulastic. I'm going to open the quiz from, hold on, I have this information somewhere. Give me a second. Okay, from 10 a.m. through 11:30 a.m. Okay, both Thursday and Friday. Okay, now the reason I'm opening it up for both days is because technically there's no school on Friday, and I can't make you do it on Thursday if you have a class in which you're going to be doing like a conference in. Okay, so I'm giving you the flexibility to do the quiz on either Thursday or Friday, okay? It's going to be open from 10 a.m. to 11 a.m., but that doesn't mean you have an hour and a half to do the quiz, okay? So you can start it anytime between 10 or 11:30, but it's going to close exactly at 10:30, okay? So don't start your quiz at 11:15, and only give yourself 15 minutes to do it. You might run out of time, okay? So you're going to submit your answers on Edulastic, okay? But in order to receive any credit, you're going to have to submit pictures of your work the same way that you would in class, right? You do your work, you do scratch work, whatever you're solving, you're simplifying, you have to show work that leads you to the right answer, okay? Because I know some of these answers can be found like in other not so honorable ways. Okay, so you are going to submit pictures of your work onto Schoology. So I'm going to create an assignment that's called Unit 6 Quiz Number 1 Work. Okay, and you would just upload your pictures of your work. Okay, so please try to keep your notebook or your whatever scratch work you're doing, keep it organized, make boxes, label the box like problem 1, problem 2, problem 3, problem 4, and do the work in that box. Okay. What do you mean, does it time each, Emily? So let's say, okay, so let's say you start your quiz. It's gonna open for everybody at 10:30. I'm sorry, at 10. Once you start, you only get 35 minutes to finish. Okay, so let's say you jump on at 10:15. Then it's gonna be a timed quiz, just like it always is. But if it's 35 minutes, then you need to be done by 10:50. Okay, but I'm saying it's an open window, so it's like you don't have to start it exactly at 10. You can start it like 10:45. Like just know that you have 35 minutes to finish once you start. Okay. There's gonna be 8 questions, but they're quick. Right. Think about the types of questions that we did for like imaginary on notes 35. Right. So real quick. Right. They're pretty simple type of problems. Doesn't take you too long. Right. Stuff like this. Okay. And then the other notes was like adding and subtracting. Okay. So you'll have some like really easy ones like example 5 and example 6. You might have a couple that are like more like example 3 or example 4. Okay. So there's 8 questions. But like I said, they probably won't take more than like some of them won't take more than like 2 minutes to finish. All right, so you should have plenty of time. Yeah, you will be able to. You'll be able to go back and forth like to check your answers. So you'll see it. It'll look very much like a quiz that we get like in class. It won't be like problem by problem slides. You're gonna get like the whole test, and then there's gonna be like a blue box that you click on the blue box. So you see like the whole test in front of you, like on a piece of paper. You click on the blue box, and then that's where you type in your answer. No, it's at your own pace, but you have the whole quiz only lasts 35 minutes. Does that make sense? Are there any other questions regarding this quiz? Okay, so I'm gonna post an update on Schoology right now, so you guys can see the details. I know not everybody's watching the video right now, so share with your friends. Let them know that there's gonna be a quiz, either Thursday or Friday. So I mean, you guys are locked at home anyway, so you decide what day. But I do want to make sure that we do it before the whole week goes by, and then you come back the week after. The work, okay, the work. You need to turn in the work. I'm gonna put a deadline. So if it probably has to be in by 12. So no more than 30 minutes after you finished your quiz. Okay. I know that sometimes there's like issues like taking pictures and uploading and stuff like that, but it shouldn't take that long to take a picture and upload it. Um, all right. Any other questions? Grades are due today. I already submitted them. So whatever you see on Schoology right now, that's what you got for the 10 week. That's why Schoology was crashing all morning, because all the teachers were in there trying to submit their grades. Anything else? Okay, yeah, let's do a homework problem. Which one? Yeah, let's do some homework. It be your own teachers. Yeah. Okay, number 8 and number 11. This is homework number 3, right? All right, let me see what homework 3 looks like. Okay, number 8. All right, number 8. Let's see. I know that there's just typos on some of these like homework answers, so you're probably doing it right, and I'm sure it just doesn't match up with the bottom. So let's go over it. Okay, here's number 8. All right, so if you distribute here, -5 times 2, that'll be a -10. -5 times -3, that'll be a positive 15i. 3i times 2 is positive 6i. And then 3i times -3i would be a -9i squared. Okay. All right. So you see your like terms here. That becomes 21i. You can bring down the -10. And then you have -9 times -1, right? You want to convert that to -1. Okay. So -9 times -1 becomes positive 9. So here you have a real number, -10, positive 9. That's going to be a -1 plus 21i. Whoops. Okay, so that's the correct solution there. And then, does that help? Good. Yeah, they put the wrong solution on the solution boxes. All right. And then number 11. Okay, let's take a look. Okay, so number 11 is -2 plus 5i times 1 plus 3i. Okay, so same idea, right? Distribute. -2 times I is -2. -2 times 3i is a -6i. 5i times 1 is just 5i. And then 5i times 3i would be positive 15i squared. Okay, combine like terms here. So that becomes -1i. You can bring down the -2. That's going to be plus 15 times a -1. So when you multiply here, that's -15. So -15 with -2, that's a -17 minus 1i. Okay. So that's what the answer should have been. And yeah, once again, they messed up on the solution. No. No multiplying or dividing. That will be the quiz that comes after spring break. Okay, so you're only focusing on notes 35 and 36. Notes 35 is the imaginary number. Okay, so it's just like real basic baby calculations on like simplifying square roots, things like that. Right, you might get one like this where it's you have a negative square root in the denominator, then you gotta extract it, and you gotta multiply by the denominator top and bottom. you simplify, things like that. Okay, number 36, notes 36 is adding and subtracting. Okay, so those are the two notes to focus on. We're good? Okay. Anything else? Any questions? You guys doing all right? Okay. All right. So that's pretty much it. If anything comes up, any questions, let me know. Unit 5 retake. I'm sure you saw the announcement already. So let me know if you are interested in doing that retake. Okay. Obviously, you never got your results back, right? Because I have the test with me. So I'm going to send a video where I show how to solve every problem correctly. So that's kind of how you're going to do your corrections in a way. You just have to watch the video and study. Okay. So if you're interested in doing that, make sure you send me a message, let your friends know. But other than that, we're done for today. Okay. Yeah, I miss you guys too. This is getting old, like being at home. I need to like feel like I'm part of society again. But at least I don't have to wake up super early, which is like the only good thing. The only good thing. And then I have more time to do other stuff. But all right, y'all, hang in there. A couple more days and then spring break, and you guys can relax. Okay. All right. Well, I'll see you guys later. Have a good one. I'm not okay. You have to send me a message first, and then I can send you the video. Otherwise, I don't know who wants to do the retake. Do you get what I'm saying? I have to assign you the test because it's gonna be on Edulastic. So if you don't send me a message saying you want to do the retake, I'm not gonna send you the video. Okay, because I don't want that video out there for everyone to see for several reasons. Okay, so Emily, send me a message directly saying I want to retake it on whatever day that you want. So you'll see the message. It should have posted yesterday. It's on Schoology. So it's either Tuesday or Wednesday. Let me know what day, and I will send you the video. That makes sense? All right, cool. I'll see you guys later.